Lesson 2, odds. So odds are a little bit different than probability. You either have the odds in favor or odds against. So for example 1, a television station is hosting a contest. Alice, a participant, can choose one of 7 doors to open. She will win whatever prize is behind the door. Behind the 7 possible doors are the following prizes. 1 offers a trip, 2 offer $20 gift certificates, 3 order restaurant dinners, and 1 door has no prize. So what are the odds for choosing the door with no prize for part A? So the way that we think about it, that's terrible, is we have the odds for, and then we have the odds against. So when we're doing odds for choosing the prize, we have the odds of it happening and it not happening. So unlike a probability, we don't care about the total number of chances. So if we were to do the odds for choosing a door with no prize, that is right here. So there's 1 chance of that happening. The chances of it not happening are the rest. So 3 plus 2 plus 1, which is 6. Or you can take the total, which is 7, and subtract 1. So altogether, your odds should equal the total. So 1 to 6 is our odds for it happening. So that's the odds for. B, it says, what is the probability of choosing the door with no prize? So the probability of choosing the door with no prize would be 1 out of 7. There's 1 chance out of 7 possible doors. We divide those two numbers times by 100 and we get 14.3%. So there's a 14.3% chance of getting a door with no prize. And the last are, what are the odds of Alice winning a gift certificate? So the gift certificate, there's 2 chances of it happening, which means that there are 5 chances of it not happening. 7 minus 2 is 5. So these are the odds for Alice winning a gift certificate. So not quite like probability, but very close. Example 2, a tire manufacturing company does random testing of tires coming off the production line to ensure that they are being produced correctly. After testing, the quality control manager calculates that the experimental probability of a tire having a defect is 0.003. 0.03. So what are the odds in favor of the tire being defective? So for part A, we can't do a lot with it as a decimal, so what we want to do is we want to turn it into a fraction. So if we count how many decimal places we move, it's 1, 2, 3, 4, which means this is the same as 3 out of 10,000. You put a 1 with 4 zeros. And the way that you can test it is if you go 3 divided by 10,000, you should get 0.0003. So these are the odds, or this is the probability of having a defective tire. So the odds for it happening, there's 3 chances for it to happen, and we need to figure out how many chances it doesn't happen. So to do that, we take our total and we subtract 3. So it's 9,997. So those are the odds for the tire being defective. The odds against, the only difference between the odds against and the odds for is you write the odds for the against first. So these are the odds against a tire being defective, and this would be useful because if you were marketing how little defects there are, you would want to put how many are good first instead of how many are bad. And for C, in a production line of 30,000 tires, how many would you expect to be defective and to be not defective? So we know this is 3 out of 10,000. We want to figure out how many out of 30,000. So we're going to look for x. So you can either do this in 2 ways, cross multiply and divide, or remember that you can times by this, which is the same as cross multiplying and dividing. So you have 30,000 times 0.0003, which is 9. So there's 9 tires that are defective, and we want to figure out the odds of this. Or we want to figure out how many are not defective. So we would do 30,000 minus 9, which is 29,991. So the odds for this one would be 9 to 29991. Okay, example 3. Determine the sets, subsets, and the number of each card in a standard deck of 52 cards. So we're going to find all of our sets. So first we have the number of red cards in a deck. We use this often. And there's 26 red cards in a deck. We also have the number of black cards in a deck, which is also 26. We can do the number of diamonds, which is 13. There's 13 diamonds altogether. And the number of hearts, there's 13 hearts altogether. The number of clubs is 13, and the number of spades is 13. The other two sets that we often use is the number of face cards. There is 3 face cards of each suit, so that means that there's 12 face cards in a deck of cards in all. And there's also the number of number cards. And we always count the ace as a number card because it does not have a face on it. So if there's 52 cards and 12 of them are face cards, 40 of them have to be number cards. Now if we were to think of subsets, we know that diamond is a subset of red, and also hearts are a subset of red. Similarly, clubs are a subset of black, and spades are a subset of black. We know that number is a subset of red. It can be a subset of black. It could be a subset of diamonds. It could be a subset of hearts. It could be a subset of clubs. And it could be a subset of spades. There's number cards for each of them. And the same thing with face cards. Face cards are a subset of red. Face cards are a subset of black. Subset of diamonds. Subset of hearts. Subset of clubs, subset of spades. So those are all of our subsets. And we know that all of them are a subset of the entire deck of cards, the universal set. So for part B, we want to determine the odds in favor and against drawing a red card. So first we're going to do in favor. So we know that there's 26 red cards in a deck. Oh, a face card, sorry. There are 12 face cards in a deck. The rest of the cards are number cards. So this is kind of the same as writing the face cards to the number cards. That would be our odds in favor. So it's 12 to 40. Against, we would write it the opposite way. We'd write 40 to 12. So the odds against drawing a face card are 40 to 12. Determine C, we want to draw the odds in favor and against drawing a red card. So if we're doing in favor, it's the same as drawing a red card, and the odds against would be drawing a black card. Everything that's not a red card. So they're complementary to each other. So this would be 26 to 26, and against, because they're the same number, is also 26 to 26. Part D, we want to determine the odds in favor and against drawing a black number card. So we have a black number card. So that means that because there's 10 number cards in each set, there are 20 black number cards, 10 for spades and 10 for clubs. So this is the same as writing the black number cards, and the odds against would be any other card that's not black, so any red card, and also any black face card. So if we were to figure that out, if there's 52 cards in a deck, we minus 20, and we're left with 32. So the odds in favor are 20 to 32. The odds against, we just write it backwards, is 32 to 20.